So I lied and I said that the last assignment was going to be the last one of 4.5. This will be the last one of 4.5. It is 4.5F, the sixth one, continuing with our sine and cosine graphs. Now we are going to talk about the importance of knowing the sine and cosine graphs, of actually applying it to real-world scenarios of sine and cosines, because sine and cosine and all the trig function graphs model real-world situations. So let's do an example, okay? Let's say for a person at rest, the velocity v in liters per second of airflow during a respiratory cycle, the time from the beginning of one breath to the begin is modeled by v equals 0.7. So let's write that down. I'm going to zoom on in here. V equals 0.7 sine of pi over t divided by 2, where t is time. T is always time. Inhalation, V is greater than 0. Of course, V has to be greater than 0. Otherwise, you'd be losing air. And exhaltation occurs when exhaltation is V is less than 0, is when you start losing an air. So you inhale, take in air, exhale, losing air. So here, my T is time, which is always going to be my X unit. My V is how much you take in air, how much you lose air. So that's going to be my Y unit here. So first, they say, find the time for one full respiratory cycle. A respiratory cycle takes in the fact that you are breathing out, breathing in, okay? And let's think about that. So what we want to do is normally our period, right? Our period is 2 pi. Well, we're just going to divide that by pi over 2 or multiply by 2 over pi to give me my period. So my pi's cancel out to make 1. 2 times 2 is 4. So my cycle is 4 seconds. This is my cycle. Find the number of cycles per minute. Well, if there is 4 seconds in 1 minute, let's see here, that's 20 divided by 4, 60. In a minute, there's 60 minutes. Seconds in 1 minute, divide that by 4. There are 15 cycles per minute. All right, let's see if we can graph the simulation of what that is. We are in periods of 2, right? We want 4 seconds. So one whole period is 4 seconds. So if I graph this, so if I did 2, 4, 6, -2, -4, -6, and this is a sine, right? 0.7, 0.7, that means that is an amplitude of 0.7. So it doesn't go up to 1, it goes up to 0.7. It goes up to 0.7. So it doesn't quite reach 1. So if I were to put in 1, it doesn't quite reach it. So let me try to do that. If this is 1, and if this is -1, it doesn't quite reach it. It will come up close, but not quite. So probably around there. And the whole period ends up at 4. So it needs to go up, hit the middle, down, right, down, and hit the middle at 4. So that is what one of them looks like. So if I continue this trend, it's going to look like that. Continue it. It's tenuous. It's not that great, but that is what it would look like in graph form. Let's try another example. Now, what if we are needing to graph, but we don't have a really easy graph to graph, and we're given a more difficult task? So here I'm going to show you how to do that, like so. Okay, I'm going to show you how to graph using decimals, because I particularly, for one, like decimals. It's prettier for me. So I'm gonna graph my sine functions using decimals. So here I'm gonna punch in y equals, so let's say 35.3 plus 25.5 times sine. So I push functions and I press in sine, and I want 2 pi t over 365. So 2 pi is over here. T is, in this case, is going to be x divided by 365. It's going to be plus 10.9. My function is getting in there. In parentheses. So one more scoot over. And the parentheses. So that is how I would graph using decimals. I like it better just because it looks clearer and prettier to me. Normally we use a graphing calculator. Graphing calc, it just doesn't look as nice. If your graph doesn't fit well, use the wrench here on the upper right corner and change your x-axis and y-axis around to make it fit so that you can see it better. So like I can make this taller if I just want to set that here, and that will give me a good idea what the graph should look like. And this function, okay, so this function I got off of a problem that says the daily consumption C would be Y in our case, in gallons or diesel on a farm modeled by this. X in this case is T. And it asks, what is the period? Well, the period is what is dividing the 2 pi. So that a period in this case is 365 days. In what do you expect? What is the average daily fuel consumption do we expect? Well, we look at our formula. Our daily average is going to be our constant, which is 35.3. Is this what you expect it to be in terms of daily fuel consumption in gallons on a farm? Yes, you need a lot of fuel for a farm. Tractors are running, equipment are running all the time. Yeah. Which value is modeled by the function that you just used, plus d that you just used? The 35.5, that's our d function. That's our d. And explain what that is. Well, that plus 35.3, that is our vertical shift, right? So that's our vertical shift up. And then the last part of it, it wants us to help pick out the graph, and we can do that with the graph that we just used.